Hello students, today we are going to solve for a side of triangle using trigonometry. So, solve for a side of a triangle using trigonometry. So, what does this exactly mean? What does solving for a side of triangle using trigonometry means? If you have a triangle and you doesn't know a side of it and you uses a trigonometric property to find the length or the side of this triangle, then this is called as solving for a side of triangle using trigonometry. So, where do we exactly use this, or what's the practical application for using this? Let me tell you. So, we all have played using kite in our childhood. So imagine you are flying a kite and you know your thread's length. Let's just assume it has 60 meters and you are not sure of the height at which your kite flies. So you doesn't know this. So at this time, we can make this as a right angle triangle, at right angle with ground and vertical. And in this triangle, we can find the unknown side, and which is going to be the height at which your kite is flying. And I will give you another example. Imagine you are standing by a building and it has a shadow, and you measure the shadow to be 100 meters. At this time, you can measure the angle made by the sun and ground as theta, and you can find this unknown side of height. Sounds amazing, isn't it? Yeah. This is what we are exactly going to do in this topic. So it will be easier to explain it with an example. So let's get back to our first example of kite. So our kite of 60 meter height, 60 meter thread, height unknown, we can mark it as h, and we measure the angle and found it to be 30 degrees. So here, this height of this kite is opposite to the angle theta. So this will be our opposite, and this is going to be our hypotenuse because it's opposite to the 90 degree. So what is the trigonometric ratio that deals with hypotenuse and opposite? Just think of a trigonometric ratio from sine, cos and tan. For ease of calculation, we are omitting cosec, sec and cot. So in sine, cos and tan, what is the trigonometric ratio that deals with opposite and hypotenuse? Yeah, sine. So we all know that sine theta is equal to opposite by hypotenuse, right? So here opposite is h, hypotenuse is 60 meter and theta is 30 degree. So here we go. Sine 30 degree is equal to opposite is h by hypotenuse is 60. So we all know the value of sine 30 from the table which we have learned. That's 1 by 2 and equal to h by 60. So by rearranging, the 60 goes here and h is equal to 60 by 2. That's equal to 30 meter. So that's the height at which our kite is flying. So this is how we find the unknown side of a triangle using trigonometry. Note it down. Okay, now let's get back to the example of building. So you are standing by a building and the building has a shadow of length 100 meter, and you measure the angle of sun which it makes to the earth, and you found that it to be 45 degree. So now we are going to find the height of the building. Let's just mark it as h. Here it's opposite and it's adjacent. So what's the ratio that deals with opposite and adjacent? Tan theta. Yeah. Tan theta is equal to opposite by adjacent. So here opposite is h, adjacent is 100 meter, and theta is 45 degree. So here tan 45 is equal to h by 100. So we all know the value for tan 45 degree from the table. That's 1. That's equal to h by 100. So h is equal to 100 meters. The height of the building is 100 meters. Easy, isn't it? Right. So now we are going to get into another example. So it's problem number 3. Okay. Imagine a tree that has broken and fallen on the ground. The tree has fallen on the ground at the broken part of tree is root 2 meter, and it makes 45 degree with the ground. And you have to find the distance from which the top of the ground has fallen from the root of the, from the original stem of the tree. So you have to find this x. This is going to be a homework for the next class. Okay class, see you in the next class.